2013 that we've been doing for warm-ups, and we're now ready to wrap it up with part B. Alright, so I'm going to record this for distance learners, mainly for when I do the disc and washer problem number 2, so they know exactly what their homework entails. Tomorrow and Wednesday we'll be doing test review, and then Thursday's a chapter 8 test. Then we have one more chapter left, but you can see there's only, if you use purple or B, C. So it's a very short, we'll be done before spring break with the course. So that's kind of cool. We're getting there. All right, so I'll just give you maybe, I don't know, I'll walk around the front row, and when they're done setting up 2013 5B, I'll have you check it. And then we're going to do one on your homework together, and then it's a work day today, just kind of to do these on paper and not on Delta Map. I might as well pause this, huh? I forgot to hit record, so here's our setup. We've got pi times the integral from 0 to 2. We said this is a dx. It always is when you're doing about a horizontal line. And we do big R squared minus little r squared. So you can go ahead and check yours. The next thing we're going to do is start the homework. So read the directions on here. We're going to add to it. So I'm hoping the distance learners actually watch this video, because I'm going to make it a lot nicer. This, where it says integrate manually by hand, like the 5th step or 6th step down there, add for 1 through 4 only. You can stop doing it. I want you to get good at that in case, like this one, was not calculator active. So part A had to be done by hand. I want you to get good at that, but it is sort of tedious. So we will do that in distance learners at home, just sort of, you can go right to math 9 once you hit number 5. All right? We are going to do number 2 together. That'll leave 7 of them for homework. All right, so go on the blank sheet of paper, write more discs and washers. And number 2, we shall do and I would use a lot of paper for these. Spread it out, be neat, use colors. The worst is when you go through one of them for 5 to 10 minutes, because they take a while, and you don't get the answer on the key. So it'll be worth your time to just kind of be really slow with them. On the key, I did not show work because we're getting towards a test. I just gave the answers. All right, we're going to do number 2 together because I think the dy is harder. So from start to finish, it first says sketch a 2D graph in the coordinate plane. Do a nice big one, guys. Don't make a tiny little graph. Use a ton of paper. I have a whole bunch up here. All right, so with number 2, we are graphing the square root of x minus 1. You should know what that looks like. So let's head out. It's our square root function like that. Y equals 0 is the x-axis, and it looks like we're going out to 5 and drawing a vertical line. So go ahead and do that. If you have colors, it's nice. I'm going to shade in my shaded region. I like the yellow here. All right, that's my 2D sketch. We are revolving that around y equals -1. Make sure you don't go about x equals -1. I like to do my axis of rotation dotted, especially if you're not using multiple colors, so you don't goof it up. I am going to draw my little arrow here. Whenever you're revolving around a horizontal line, it's a dx problem because we go perpendicular to that, which means that a representative rectangle, which you're going to draw, its width is across the x-axis here. So this is a dx problem, and it says in bullet number 3, it says decide if it's going to be a dy or dx setup. So you're going to write dx. So I've actually got 1 and 3 done. I didn't sketch what the solid's going to look like. So I'll do that right now. If you picture what the solid's going to look like, I'll do it dotted. It would go like that. And it would have like that, and that would have been shaded in, and it would sort of have this on the bottom and that like that. So it's going to be sort of like a sideways bowl. So you can go sketch that off to the side if you want to. It doesn't have to be beautiful. It just needs to be clear that there is a hole drilled out of it, that's good enough. Like, it doesn't have to be great. I'm going to erase mine over here. I just wanted you to get a good picture of that. So is this going to be a disc problem or a washer problem? What do you think? How about Shunk? Disc or washer? Washer. Yeah, that rectangle inside the rectangle never leaves the shaded region. It's the solid part of the figure. But I have this empty space in here, which I said to connect with some dental floss if you want to. But yep.
Isn't it supposed to be on the y-axis?
Yes.
For number 2?
Yes. Dang it. It did say it about the y-axis. I was reading the prompt for number 1. Shoot. Well, number 2. I was reading about the line y equals -1 from number 1. You got to change it. All right, that totally changes the figure too, doesn't it? So now it's going to kind of have, this figure is going to be like this. It's going to go like that, and like that, kind of like that. And we're going like that. And we do have space in there. Again, it doesn't have to be a beautiful 3D figure. Just, I kind of want you to be able to visualize it. All right, so now I have to erase this. You might want to just start all over. Thank you, Kaden, before I finish the whole thing. All right, so let's get number 1's axis of rotation off of here. Sorry, guys at home. I didn't read carefully enough. All right, so now when I draw my representative rectangle perpendicular to the axis of rotation and I don't leave the shaded region, and I realize it's not butting up against the axis of rotation, I still have, now I have a dy problem. It is still, as I asked Shunk, a washer. It's only when it's completely butted up against the axis of rotation. All right, next up, we need to decide what our big R is. And for this one, I think I want you, this is why I chose this, because big R tends to be an issue. Big R is always the axis. So you put your pen on the axis and you go to the outer edge of your shaded region. If you want to actually get a visual of what big R is, I'm going to go blue again so you can see me. I always say go to the axis of rotation and you're going all the way out to the edge of your shaded region. No matter where you drew this, what is big R? There we go. No matter where you put your rectangle, what's big R? 5. And it's still right minus left. It's just 5 minus 0 in this case. So I'm going to write right minus left. If it was a dx problem, it would be top minus bottom. So in this case, it's just 5. It's really 5 minus 0. Big R is a 5. Everywhere. It's constant. You can see it over here, like on my 3D. This is not varying. Little r, though, is varying. Little r is the dental floss, or this little invisible piece, the radius of that inner empty space. So little r is still, you go to the axis, whether it's to the left, right, up, or down. You put your pen on that axis, and you go to the inner edge of what you shaded. Okay, so I'm going to go axis to inner edge. I'm going nice and slow because it's Monday. All right, Mondays are kind of always a regroup day. That green piece, no matter where you put it, is little r. We still do right minus left when it's dy. But on this, the right function is not always 5 or 6 or 7, but it is always on the curve. It's the x value, correct? What's wrong with mine? I was given y equals the square root of x minus 1. I don't want the y value in there, right? I don't want how high up it is. I want how far over. And because I wrote dy over here, I know that I have to solve this. So I would have y squared plus 1 is equal to the x value. Make sense, Luke? We good? So I'll do right minus left. This point right here is now the point y squared plus 1 comma 1. So let's go do that. I do right function, y squared plus 1, minus left, which is 0. But keep in mind, if this had, watch this over here, guys. If it had said to go about the line x equals -2, then I'd have y squared plus 1 minus -2, and I'd be adding 2 on. I see nods over on this side. How about you guys? Okay, And so now I'm ready to set it up. So there's 7 of them you're going to do, and you might say, oh, only 7. If you're going to get them right, they take a while. So here we go. My volume will equal, don't forget your pi. I'm going up the y-axis. From 0 up to. Up to what? Good question. From 0 up to what? What do you think? What do you think, 40? 0 up to where?
The intersection.
Yeah, be right here. What point is that going to be? When x is 5, y is 2. So, again, if this had gone, if it was the one I drew before that was wrong, we would have been going across the x-axis from 0 to 5. But remember, dy up the y-axis. I do big R squared, should be 5 squared, minus little r squared. This is not one where you're going to hop on in Math 9. You'll have 3 of them now, because I'll do this one. But this is one you're going to do by hand, and you're going to watch your arithmetic, and you're going to try to stay off your calculator. Okay, you can just use your calculator to check it. So I need to FOIL in there. I have 25 minus, and then I'd have y to the 4th, outside, inside. Correct me if I do arithmetic wrong. It's not my strong suit. I'm good. I FOILed her all out, right? And then you're actually going to clean up your integral by hand. And you're going to have a negative y to the 4th minus 2y squared plus 24. Am I good so far, guys? I'm good, right? Yes? Now I'm going to anti-derivate, Priestley. Go ahead and tell me the antiderivative of y to the 4th.
Y is negative y to the 5th over 5.
Yes. Y to the 5th fifths minus 2y to the 3rd thirds plus 24y, boom, 0 to 2. Love the bottom boundary of 0, but I'm like, ugh, putting that 2 in this is not fun. But I'm going to do it, and I'm going to do it by hand, and you guys are going to do it on 3 of them. All right. So when I put in the 2 and raise it to the 5th, that's 32. 2 times 8, 16. 24 times 2 is 48. By the way, if this was, I'm going to have you stop for 1 second. If this was FRQ, you should stop here. All right? You are allowed on non-calculator FRQs to leave it all numerical and unsimplified. The place where they check that you know how to simplify is on the multiple choice. You won't see this on the multiple choice. So you have to know how, but if this was a piece of an FRQ that you had to do by hand, do not, if you do it wrong, you'll get the point taken off. Does that make sense? But we're going to pretend it's multiple choice, Annika. And I said that you should go all common denominator. What is my common denominator? Go ahead, Annika. What's my common denominator? Yeah, so I'm going to do everything 15ths. So on the key, you'll see there's a 15 in my answer on the denominator. All right, so this isn't too bad. I need to triple, negative 96. I need to go times 5, which is 80. And I'm not going to take out my calculator and assume it's multiple choice. I'm like, oh, crap. You better know how to multiply, right? I'll go do it, hopefully correctly, because I hate arithmetic. You might say, why do you make us do it? Because there's at least 1 or 2 on the AP exam where you have to do your arithmetic correctly. So as much as I love to say go use your calculator, I'd be doing you a disservice here. So what am I doing here? Where was I? I was at 0, period, that's 4, 24, 8, 4. Am I doing okay? I feel like I made a mistake. Did I? I'm good, right? So far, so good. 720. All right, and then what? Finish it off. You guys can go ahead and finish it. I don't feel like it. Anyway, so you need to show by hand, but then you can check on your calculator or I posted a key. So you have 1 and 3 through 8 to do. Once you hit number 5, they're going to go fast. Why do I say that? Because you're going to just set it up and go right to Math 9 in it. All right? But the first three, you're gonna get a little frustrated. That's okay, you have half an hour. The bottom three will be like the delta math, where you can just go ahead and, or four, I mean. Have fun, I'll turn the radio on. I think you should get 544 pi over 15, right? Yep, that's what and that's what you'll see on the key. You won't see all the work. So that's why you gotta go really slow today or your answers aren't gonna match the key. Nice and slow. If you have any questions, let me know. You guys haven't been asking me much on this stuff, but your delta math's been looking great. I do look. So I'm just gonna give you work time.
That face that usually comes by his phone, that's finally made it again. That face wouldn't be doing that.
CBC noise yet?